Hello everyone, and welcome to the Engineering Applications Open House video. My name is Anthony Truss. I teach at Conard High School in West Hartford. I'm going to keep this video to about 5 minutes in length, and this video is intended to provide a course preview where otherwise you would be with me in my lab in person, where I'd walk around and kind of give you an open house tour. I'm going to try to do this in a digital fashion. I realize that it's definitely a poor substitute for the in-person meet. However, due to this year's platform and the way that we've decided to go, everything is going to be remote. You're going to receive a link, I believe, from the district that gives you the live link to my open house scheduled time where I'll be able to meet and talk with you in person. This video is intended to be watched prior to kind of give you a general understanding about the course before you meet me in person, digitally. So once again, this is for engineering applications. I use the Google platform or the Google Classroom platform pretty extensively. Currently this year it's in 5th period, in other years it'll be a different one. I try to train students and to let them know that they should be clicking on the classwork tab to keep track of what it is that they need to do week by week. I organize my content by week blocks. I find that students like to know what it is that they need to accomplish for that week, regardless of topic. So I don't topically organize my classroom, but I chronologically organize it. So I ask students to just keep a track of the due dates and the week time frames that they were assigned within. There'll be resources that are attached that can help students do the various projects and so forth. Of course, lessons accompany all of the content that you see here within the classroom and so forth. So at this point, don't think that students are just given the material and then expected to just consume it. So there's lessons and activities and discussions that go along with all of this content. So what are we going to be doing this year, specifically speaking, is studying the application of engineering in all of the different ways that it can be. Engineering is a pretty exciting field. It's rather subtle to the average person that's not involved in the technical careers. So this class is intended to show the subtle underbelly of engineering and how it affects all of us and we benefit from it and how we can participate in it as well. So we focus on technical communication. It is intended to be a second-year course following the first year, which is architectural and engineering design. There are some exceptions where there's a few first-year students in, but the majority are second-year students who can help out the first-year students if it's necessary. So the first year is focusing on technical communication, kind of outside of the context of the application, where this class is focused on the application. So students will be designing and fabricating various projects in labs with all kinds of engineering resources and tools to study the concept of this applied engineering theme that we have this year. So some of the tools that we're going to be using that they used last year as well would be SolidWorks. It's a parametric 3D design or modeling platform that's used specifically by engineers to mechanically engineer various products. It's not just a simple 3D modeler, but it's also a finite element analysis engine where we can run flow analysis, stress analysis, and so forth as if it was a real live test. It can give us yield strengths and so forth to let us know when that material safety limit has been exceeded. So we can do some in the computer tests that otherwise would be dangerous in a safe environment, and then study the data that outputs it. This is just an example here of just a simple piece of hardware. So we're going to focus on obviously hardware because hardware is what holds everything together. We'll be making some mechanical drawings of hardware, focusing on threads, mechanical threads, SAE, metric, and so forth, as well as using some of the canned hardware that SolidWorks provides us. We will be using 3D printers. This is one of the 3D printers. We have two different flavors of 3D printers at Conard here in my lab. We have an SLA printer, which works on photopolymer and UV light in a chemical reaction type of process, a chemical process. And we also have FDM 3D printers that uses a mechanical melted type of plastic layered down, deposited layer by layer, which is more of the traditional 3D printer. So we have two different kinds for two different types of applications for various engineering purposes. We also have a laser engrave station in the lab. We have them in two different locations, one in graphics and one in the manufacturing lab. It's a 120 watt CO2 laser that we can do some pretty amazing things with. The area that we have is a 3-foot by 4-foot bed, so we can do some fairly large things, or do large productions of small things. So we'll be focusing on obviously manufacturing as well, so that's kind of where this comes in. As well as this. So this is a 4-foot by 8-foot CNC router. This isn't the exact same one that we have. We have one that looks pretty much the same, except it's green. It's basically a $40,000 industrial robot that I wrote a grant for, and we were lucky enough to have that award. So this is like a 3D printer in reverse. It uses the subtractive manufacturing process where it removes material through the use of cutting tools. So students will be making their own programs, executing them, and then cutting them out safely on the CNC router, as well as using the same concepts with the laser as well as with the 3D printer. So we have all these different tools for different projects, and making students become confident that they can use these tools independently, at least these two, is important so students can execute their own ideas when they're ready to do that. The CNC router, I like to see independence on that. However, students aren't going to be using this one alone. They have to work with me directly for this. Currently, what we're doing right now is we are focusing on engineered systems. The whole entire year, we're going to be focusing on engineered systems. We're going to jump from topic to topic just to focus on a specific engineered system. So for the first activity, we focused on a standard carburetor and understanding the different valving that goes on inside that and the scientific principles such as the Venturi principle and the concept of what a siphon does and so forth. Just so students can understand how valves work, how a complex system of simple scientific principles put together in a combination can achieve some sort of goal, such as the aspiration in a carburetor. Moving forward, what students did with that knowledge is we focused on hand sketching techniques, where students need to develop their hand sketching ability. So we focused on a couple activities and lessons, and then after focusing on that, they had to apply their knowledge of the carburetor to create a hand sketch. So they're applying their newly developed hand sketching skills with their newly found information about a carburetor to kind of prove to me that they were able to gain some skill in sketching and understanding a technical system. So for example, here's a carburetor sketch that a student turned in this year that kind of explains the two different valve states that are open and closed for throttle and choke, how the Venturi principle will pull out fuel from the bowl where there's a float that takes the fuel from the fuel tank. Here's another example of a student's drawing. So this is after we've practiced technical illustration and studied it. It's a fairly nonverbal type of experience where we are just kind of annotating, and these are just some really good student examples. We're focusing on just general valves next, and so we were focusing on what a siphon does and what the greedy cup siphon can do and how it's actually used in industry. And actually this kind of technology is actually in your washers for various solutions and fluids to be properly distributed at the right time. So once again, very subtle engineering types of activities where it's the wow factor of like, I have this, it's pretty mundane, but then once we look under the cover, we can kind of find the scientific principles behind the system that we use, and hopefully apply these types of solutions in open-ended ways in the future. So right now it's just experience building, playing with the content, understanding engineering principles so that we can kind of creatively think and play down the road. I think in terms of time, I have gone over, so I apologize that this video has gotten longer than it should. But lots of exciting, fun things to talk about and share with you. So I look forward to seeing you in the open house one-on-one meet when it comes to the digital side of that. If you have any questions or comments, please reach out in the email, and I will talk to you in person shortly.